Is my mic on? So I don't have any training data in my thing, so we're taking a little change. Hi, I'm Steve O'Connor with Flux Tensor. We do ubiquitous identification of any type of objects in complicated environments, and we don't require any training, and we can use any camera there is. So just a brief background, I am technical by nature, so we're gonna geek out a little bit on math. So I have a PhD from Caltech. I've been doing startup companies for about 30 years. So this is our problem. There's about 1 billion security cameras around the world, all right, with a B, on right now. Every kind of flavor, IR, RGB, grayscale, old, new, et cetera. And it's so many, nobody's watching any of them, or almost any of them, okay? And it is too many, and it would require too much computing power to do AI on all these cameras, all right, especially the old ones. So that's the problem we're dealing with. So they're almost all used as, hey, something happened yesterday, let's go back and check and see what happened, all right? So what we do is we only do math, okay? So we don't do any deep learning. We take frames from a video, we analyze them in 3 dimensions, then we take another one and another one and another one, and we create 4-dimensional tensors on that and do some complicated matrix math, and those things look different for real objects than they do for non-real objects. So shadows, lights flickering, wind when you're outside, et cetera, look very different in that 4th dimension. Then we take those and do some more to see how those change over time, which I'm kind of calling it a 5th dimension. And that looks different depending on what you're looking for, okay? So they're very generic. There's no training required on any of these. Any camera matters. It's inherently temporal, not static, and it requires really low computing power, okay? Because we're not training anything and we're not having any lookup tables. So we can do this on the edge, no problem. We can do it on a CPU, a GPU only, any combination of the above, and we do them on any type of computer you want. So it's really ubiquitous for existing systems. This just shows the core capability, and we'll see if this thing runs. This is not a demo slide. Is this thing gonna run? Oh, there, whoops. There we go, there's a big lag. All I wanna show you is this video on the left. What you see in the middle, well, you might not see it. Well, you'll have to come to my booth to see it. It's really freaking cool. Basically, we take the video on the left, you process it in real time. Oh, there we go. And what you see is in the middle, all right, with no training in real time, all right? So all it's doing is getting rid of everything except for the cars, all right? It's snowing, there's shadows, there's lights flickering, and we can do that in real time. Inherently, we have no PII information in what we produce. It's blobs, okay? But we can characterize those blob-like objects in terms of what they are, okay? So if a customer is ever worried about PI information, we don't need any for ours. The way we envision this is all the cameras come in, we process the data, and we can give real-time alerts. All right, hey, you need to look at this video right now. There's something bad going on. All right, and then you have a human verify what it is. You can also then trigger AI where you say, hey, I ignored 99.9% of the video. I didn't need a lot of computing power, but hey, I found something now. Tell me what it is. So we could trigger AI, and we're actually doing that. Or we can do smart storage. This is a brief demo of our product, which again, hopefully this will run. Oh yeah, here we go. This is the exact same algorithm on multiple different video cameras. What you're seeing on the bottom is a couple train stations at night during the day. The top is a garage. Couple different garage scenes, same algorithm, no training. You can see in the bottom left, there's a guy that actually leaves a bag behind a post, all right? And as soon as that happens, we'll draw a circle around it because we see it with 0 training, all right? But then the train moving on the right-hand side does not trigger the system, nor do the shadows. You can see the guy in the top. You see that thing in the way far back, a human being wouldn't even really see that. I couldn't see it when I watched the video. So anyway, again, I wanna make sure you know this is totally generic. We don't need any training. Cameras change in the field too, by the way, y'all. They get dirty, things get bumped, right, they change, and no one is gonna go clean those things just for us. So what we're seeking is we have multiple site deployments we're working on right now. We're actually in the TSA test bed being fully analyzed in their Massachusetts test bed. We're looking at some additional ones we want. We're already existing into existing software platforms, so we're integrated into Genentech, Reolink, and Ultralytics in terms of those capabilities, and we want more partners. I want to partner with AI companies, not replace them, where I look at all of the cameras, and then we can trigger them when need be. As well. So that's what I got. Thanks. Oh, I'm supposed to go forward.
Okay, so as you're looking at, you said real time, got it, but how are you actually flagging not the train, but yes, the bag?
Right, because in that fourth dimension, the fourth dimensional vector tensors have a different profile that can be filtered out than things that stay behind. All right, because that train kept moving, and if the train stopped moving, the train has a gargantuan vector because it's so physically large. So I would filter that out as well, but only in that fourth dimension.
And you're using math to filter that out in the fourth dimension so that therefore what is left is the bag is the difference, and then you're flagging then it's automatically flagging the bag. It's not a human in the loop flagging the bag.
The math flagged that bag.
Got it.
It's flagging a bag-like object. I want to make sure that's clear. It's flagging a bag-like object.
No, I appreciate it. Thank you so much.
Great presentation. I've never seen anything like this. Could this approach also be used to detect or to separate synthetic imagery from genuine imagery?
Ooh, I don't know. I don't think so. Yeah, I don't think so. Yeah.
Great presentation. Question though, you've highlighted you're not using deep learning, but then you mentioned triggering AI and machine learning. So I was trying to make the connection between the two. What aspect of machine learning are you using?
Okay, for all of the analysis, none. But in our software stack, we can plug in deep learning at any point you want. So it only has to do the deep learning on 1 out of every billion frames. Okay, so then your computing power is not problematic. So we currently plug in like YOLO 8. Just to differentiate between people, cars, bags, et cetera. But it doesn't have to be part of it. We could plug anybody else. It's just part of our stack where you could slap it in there, but that is not our core capability.
Understood. Thank you.
Yep.
And while you have a few extra minutes.
Oh. I was quick. I didn't go over my 5 minutes.
There you go. That means you get more questions.
Yeah, that's right.
Okay, so when you're thinking about the commercialization and where are like the top places you're looking at for commercialization, and where have been the places where you've really seen product market fit and it just like has hit and the operators really get it?
Yep. Okay. So us as a company, I only want facilities or customers that have more than 500 cameras. We totally don't mind doing demos first because we're going for, because we really make the most difference where there's a bunch of cameras. We are already partnering with existing people to handle smaller number of cameras where I provide them my APIs and SDKs, they integrate it into their current system, and they just provide the solution where I don't really have to do anything with the customer other than collect, a smaller percentage of their monthly sale where they're building into their existing video management software. So I don't really care about any of those. The biggest safety customers are the ones that almost never have an alert, almost never, but it would be catastrophic, like remote power switching stations, where if there was someone out there doing something bad, it would not just hurt that site, it could potentially hurt. That's probably the biggest need, and nobody's looking at any of those cameras at all, at all. So, but there's a bunch of other ones too. But I only care about, for me personally, for us to go direct large number of cameras where people are ignoring most of them. And then, by the way, no one asked, but I'll go ahead and tell you. Then it'd be $1 a day per camera. It's $1 a day.
Okay.
And that's it. Nothing up front.
Have you looked at different military installations? Have you gotten good use cases on base? Because there is some NCO who is like, please tell me when the alerts come because I just stare at a camera all day.
We had, and maybe you, since you are helpful with we had money from the ARL and the Air Force and the Navy during the early development of this from the academic group, and then the company had, and then it just stopped, even though everything worked, because they're like, oh yeah, we don't know the procurement people. So,
That is not surprising.
Yes, I'm like, wait a minute, you said you were going to help me. And they're like, yeah, we don't know who any of those people are. So,
and a lot of those bases and installations end up buying very separately, so it's not an enterprise purchase. But we'll talk after.
But a base would have sufficient cameras for sure. And listen, I'll take any use case that then I could leverage into other customers and say, hey, they're just like you. So yeah.
Thank you so much.
Great, thanks.
Thanks, Steve.